So there are a couple of Google Colab notebooks that you can go through with your students if you want them to see what the code looks like. These are image recognition notebooks. And the nice thing about Google Colab notebooks, I don't know if you've seen Google Colab notebooks before. The nice thing about Google Colab notebooks is they are kind of like Google Docs that also can run code. So in order to run code, you just press the play. It will warn you anything that's not authored directly by Google. They can't promise you you're not running bad things on your computer. I know the person who made this. I can promise you you're not running bad things on your computer. Oh, I need to run this first, loading all the libraries. But since this is like a Google Doc, every part of it is explained in words. So you can just have your students read through it and run the individual libraries as they happen. I haven't had this error before. It's probable that we need something new. So yeah, it tells you what generally is going on in each line of code. This is why I talked about data pre-processing. Real world data is hard. Here's how they're making the real world data into better machine readable data. Here's how they're building the model. On the second, I think it's the second project. Yeah. So on the second project, if you scroll all the way down, let's look for epoch. Yeah. When you're training the model, you can change the batch size and the epoch. And that's really the only actual changing of this code that your students would be doing. And it tells you exactly where to do it, but you can see what having more iterations of looking through the code does. You can change what seeing more images or less images does, and what that does to the performance. So this is if you want to really, really dive into the weeds, you can look into these. So we talked a lot about the useful things AI can do for the environment. Other impacts AI can have in the environment. Remember, we mentioned that thing about the processing power. Machine learning takes a lot of processing power. The more processing power you require, the more energy it takes. And using all of that energy is a problem for the environment. It makes carbon pollution, etc. So and the computers themselves, once they stop working, you need to throw them out somewhere. So yay, machine learning. We can keep track of populations of animals much easier and maybe rescue them. But also, we need to consider the environmental impacts that doing all of that has. So talking about environmental impacts, one of the teachers wanted us to add this as well. When you're talking about environmental impacts, it's also important to note that marginalized communities are often most hurt by bad environmental impacts. So this is a video about environmental justice and how people through politics and have attempted to make sure that there's laws and such about environmental impact and trying to make sure that it doesn't as much disproportionately hurt marginalized communities. So we talked about that, but I am, very, very out of time. So here's some things that have happened in environmental justice in the past several years or so. But there's also other ways that AI can be helpful to the environment. They can make better maps. Self-driving cars are better for the environment than everyone driving in their own cars often. There's a whole article that I link here about all these different ways that AI has been used to help the environment that aren't just following it. Yeah, that one is weird. I do not fully remember that and should explain. Um, they also found poachers for the same sort of way that we were following wildlife. Um, that is able to figure out where people are likely to be poaching and save wildlife that way. Then want to talk about what we can do to help minimize AI's harmful environmental effects, which is in part just think about it. Realize that when you're using a lot of computers, you need to think about how to use those computers effectively, where you're going to throw them out and such. And then always ending with people involved in something similar. So this uses a lot of computer vision. This woman, Mumita Roy Tora, did some research figuring out where different people were on a hockey field. So you could figure out how the groups work together and be a better coach. And Timnit Gebru, who has worked at Google in ethical AI and studied algorithmic bias at Microsoft. When she was a PhD student, did work figuring out about just through images of cars, what can we learn about the economic status of this area and voting patterns and figure out where inequality is happening. So hopefully we now can talk a bit about how AI can be used as a tool, especially in cases to help conserve wildlife, and think both about what makes it an effective tool and also what problems it has. And that's everything. Sorry for having rushed through the end. I was trying to base that correctly, but
Awesome. Thank you, Sarah. Yeah, that was really wonderful, thinking about connections between those different spheres, and thank you. Yeah. Okay, what we're going to be talking about next is AI curriculum. And then that's going to lead into your goal setting for today and the breakout rooms or breakout individuals, whatever we want to call it, where you're actually going to take a solid chunk of time, and it will be longer than yesterday, almost an hour, to really dive into one curriculum or two, but really focus in on exploring one and then reporting out to the rest of us what y'all think about it. So I'm going to go ahead and start you thinking about that. We're back in just our main slides for today. I don't have separate slides for the curriculum. But so Nora and I sort of brainstormed, and we used what we had seen from various presentations, including some from the CSTA conference this summer, including from the AI symposium that was back in April, and including, of course, some of the connections we have. We listed AI for All here, of course, as a full curriculum that you've been hearing about from Sarah. And we brainstormed and we narrowed it down to a couple. We've got, I guess, 4 full curricula here, or like at least unit length, 30 hours or more. And then we've got a couple sort of extended resources that might not be like a full curriculum, but still long enough to take some time that might be worth delving into. So we'll go through each of those briefly. Some of them I'm going to talk a little more about to introduce you, some of them that might be newer to you. And then we're going to ask you to pick one of these 7. Or possibly 2, but I think we could probably get more out of just really spending that hour on one. To really dive into the curriculum and explore some of the lessons and explore some of the activities and explore some of the slides, right? If there are slides, and really dive into it. And maybe even think about what changes would you make to it if you wanted to incorporate that into your class or to your situation, right? I know some of you are working at central office, so however you would need that. So starting out, we have AI for all open learning that again, you've been hearing about from Sarah. She mentioned it was high school written and middle school tested, written for high school students, but it still works with lots of middle school students. And that is very, and I've also tried to put the summary of the number of hours of curriculum that are there. And some of them are modular, like you know from AI for All. You could pick just a 1 hour bite, or you could do up to like combine all of their curricula together. I think I added it up. Sarah, correct me if I'm wrong. It's over 90 hours of curriculum.
Yep, that's right.
And then the daily curriculum, we heard a little bit about yesterday. I was mostly doing an activity from daily. I didn't really talk to you about what the curriculum was all about. Then there's the elements of AI, which is geared towards high school. And I've tried to write high school or middle school. There's not that much out there for elementary. So I would consider for the folks of you who work mostly with elementary school, that you might want to possibly do this family AI challenges down here, because that could be families, including an adult and a kid of any age. Or maybe you want to explore one of the ones that's written for middle school and think about, well, what changes would you need to make to adapt it for elementary school? So yeah, elements of AI is geared towards high school. And then this one is new, the code.org AI unit. And that's really geared towards that CS Discoveries class, which I know at a lot of schools is high school, like 9th grade, but is also offered in many middle schools, like 8th grade. So that could be sort of middle/high. And then there's, these ones aren't full curricula, but the MIT App Inventor AI Lessons is a cool one that I just heard about this summer. And so I wanted to share with you a little of that. The Technovation Family AI Challenges, and then the MIT Media Lab's AI Ethics Curriculum. So let's take a moment and just look at each of those. So I copied this slide from what Sarah shared with you yesterday from AI for All, sort of how it's broken down into modules and which pieces you might want to choose. If you do choose this one to explore, I would recommend, since Sarah's going to be covering, has already done AI and drawing, environment, facial recognition, is going to do dance on Friday, that you might want to look at maybe either the AI and ethics, that 10-hour chunk, or maybe the Explore AI 30-hour curriculum, and sign in, right? Create an account for AI for All and sign in and start exploring what do those lessons actually look like. Something that she's not